Welcome back to the Rule Your Pool podcast. This is episode 119. And today's episode, I'm recording from a place that I've never been in, Tyler Mills' apartment in Phoenix, Arizona. Tyler, thanks for being back on the show.
Thanks for having me again, Eric.
Tyler, you know what we're talking about today?
We're talking about fiberglass and vinyl liner pools, which is something I don't have a lot of in this market.
Yeah, you cover Arizona, Nevada, Colorado. Not a lot of vinyl liner or fiberglass pools in the Phoenix market. But the big questions that we get on the helpline, and you've received some of these, I'm sure, is why is my fiberglass pool turning white? Or why is my vinyl liner fading? Or how much calcium should I have in my pool? Because the manufacturers will say, oh, don't have more than 200 parts per million calcium. And I'm here to tell you, listeners, the LSI is still the LSI on everything, and that's what we're going to talk about today. Do you have anything you want to bring up before we get into this?
Yeah, last time I was on here, I said something. I think you remember what it was, that I was coming for Jared's job, and I wasn't joking about that. So it's still going to happen.
Well, how prepared are you for this? How many episodes have you listened to?
5 to 6.
Yeah, you really are coming for his job. We have a very low bar, and that's exciting. So this is episode 119 of the Rule Your Pool podcast. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. You know what I find interesting? It's this myth that if you have a cement-based pool, plaster, quartz, pebble, whatever, that your pH is going to rise because it's a plaster pool. And we know that the pH does naturally rise, but it's not because of the cement, hopefully. Now, I'm going to ask you, why does the pH naturally rise, Tyler?
pH naturally rises due to the loss of CO2. And we know CO2 dictates what the pH of that water really is, the amount of CO2.
Very good, Tyler. So elaborate on that. We know we've got CO2 in the water because we have carbonate alkalinity. And we know that CO2 determines the pH of the water, but why does that make the pH rise?
It makes the pH rise because we know that CO2 is off-gassing from that water to equalize with the CO2 above the atmosphere. Now, if you've heard our classes in the past, we usually use an analogy to explain this. So let's think of a soda or a beer. So, Eric, I hand you a bottle of Coke. Before you open it, is there any bubbles in it?
No.
Now, when you open it and you twist that cap, what noise do you hear?
I hear CO2 escaping from the bottom.
And the same thing's happening in swimming pools. It's off-gassing to equal the partial pressure of the atmosphere above it. So over time, less CO2 is in that soda. Therefore, it becomes flat, and our swimming pools are going flat all the time.
Very good. You are making a run for Jared's job. Good for you, Tyler. Okay, so we do know that the pH does naturally rise due to the off-gassing of CO2. That's a fact. The myth is that if you have a cement-based pool, that it's rising because of the cement. And what we're here to tell you is that's not necessarily true. In fact, we hope it's not true. It can be true if you're running an unbalanced LSI or you're overcorrecting with acid and the LSI ever goes red. LSI, of course, if this is your first episode listening, is the Langmuir Saturation Index, which is the index that we use to measure the balance of water. If it is aggressive, that water's hungry and it's looking for calcium. So it's going to dissolve it anywhere it can find it. In some plaster pools, many, I'm sure, if they are mismanaged or they are using trichlor as a primary chlorine, which is acidic, and the CYA gets up and the LSI gets more aggressive, yes, you could be dissolving calcium hydroxide, which does have a high pH, 12.6, and that will spike the pH. But that's spiking the pH. That's not a natural rise. And as we've spoken about in previous episodes, the natural rise of pH takes you up to the pH ceiling, which in the Orenda calculator app is a secondary reading, so you can see it. If your pH ever goes over that pH ceiling, something forced it to be that high, and usually that's overcorrecting with acid that dissolves cement. But how could that happen if your surface is a vinyl liner or a fiberglass pool? So this is where the myth comes from, and I'm here to debunk it. It is not supposed to be the cement that raises the pH in these pools. Natural physics will do that with the off-gassing of CO2. Salt systems just accelerate this because they bubble off CO2 within them due to the hydrogen bubbles, and that creates turbulence, and therefore the pH rises from there. Let's get back to the vinyl liner and the fiberglass. The thought that is prevalent in our industry is that if you don't have calcium in the material, like in the surface, you don't need as much because you don't have to worry about calcium because it's not a calcium surface, so who cares? And we actually have seen this in so many words, I'm paraphrasing, of course, in manufacturer warranty documents for fiberglass pools and vinyl liners. I've seen documents that say don't go over 200 calcium. I think it's all based on the old way of thinking that these pools are a lot more prone to get scale. And so you see scale, or at least you see white deposits, and therefore people think it's scale, even if it's not. And that has eventually evolved into a habit of saying, hey, I want to avoid that problem, therefore have less calcium. We saw the same phenomenon in the Northeast 5 or 6 years ago with the crystals. People thought it was scale, and over the years, they were tired of opening up the pools to crystals, so they said, I'm sick and tired of this scale. I'm going to dilute my water down and lower the amount of calcium in it so that I don't have scale, which of course made the crystals worse because it's opposite of what you should have been doing. It was always an LSI violation. So let's talk about what the LSI does to vinyl liner and fiberglass pools. Again, you don't have many here in Phoenix. Let's start with you. What can the LSI do to a cement-based pool, whether it's plaster, quartz, pebble? What can it do if the LSI goes purple?
Well, you'll start to see scale forming, typically in the hottest parts of the pool first. So think tile lines, spillways, things of that nature. I've even seen it so extreme where the pool's pretty cloudy, and the cloudiness actually came from just super high LSI water.
So it's actually precipitating calcium in the middle of the water.
Yep, it needs to get rid of some of it to put itself back into balance, so it does that through the water.
Okay. How about salt pools? What do you see in salt pools?
You see scale buildup in salt cells.
Which flakes out and blows in past the returns and all that. Okay, you ever seen white dust at the bottom of these pools?
I have.
Okay, how about plaster startups? You ever seen plaster dust?
Seen lots of it, yes.
Localized LSI violations. Here we go. So that's what you can see in that type of pool. A fiberglass pool doesn't have any cement in it. A fiberglass pool is protected by a gel coat. And a gel coat is made up of polyester resins, pigments, and catalysts to harden it. What happens is, if the water is aggressive, it is looking for calcium. It is starving for calcium. And it's going to start degrading that gel coat. It's going to start gnawing away at it. This is a highly scientific term, Tyler. Just go with it. You live in the desert, so you know this, but you know, like in the Mojave Desert, it doesn't rain and the ground is all flat and cracked, kind of like those old skin commercials, like, is your skin dried out and cracked?
Yeah.
If you were to zoom in with a microscope on a gel coat. It kind of looks like that. And then chlorine can get into those cracks and it can start oxidizing the polymers in there. And they turn white. This is what fiberglass chalking is. Now, I call it chalking. Most people that we've talked to know what I'm talking about when I say it. It's that white haze on a fiberglass pool. That is not scale. If it were scale, it would only be at the water line or in the hottest places first, and it would come off with diluted acid, and you could balance it and clean it off because it's on top of the gel coat. But anybody who has seen this knows this stuff doesn't react to acid. It's a discoloration of the actual material because chlorine got into the gel coat and started oxidizing it and turning it white. Huge difference. It is a low LSI violation. It is not scale. It's the opposite of scale. And unfortunately, it's permanent damage. So LSI balance in a fiberglass pool is really, really important. You do not want that water to be aggressive. And if you have a fiberglass pool in a cold climate, I'm from Northern Virginia, anywhere, mid-Atlantic and north, those pools will freeze. And if you have less than 200 calcium, you don't have the insulation to get through the wintertime, and you are bound to have some destruction of that material in the wintertime. And the same thing goes for vinyl liners. I know they're not here in Phoenix, but have you been in markets where you've seen fiberglass and vinyl liner pools before?
Yeah, I have. I was just in Mesquite, Nevada, went and saw one there and a couple in Colorado, actually.
When you go and see those pools, did they have a problem? Like, why were you there?
I was called there because they had some issues with cloudiness.
Oh, cloudiness. So it wasn't like a fading liner or anything?
No.
Okay, we would get a lot of calls about stains on liners, but fading is a big one. Now, there's a difference between fading and yellowing. If you have a vinyl liner pool, we're switching gears here. Yellowing is typically from exposure to UV light, so long-term sunlight, and chlorine. Pigment loss, fading, is usually an LSI violation because it's actually removing material. People think it's bleaching it out. That's generally not the case. I can't say that it's not part of it. Perhaps it could be, but to actually remove pigment, you need to remove material. And as luck would have it, inside your vinyl liner, all of them, they do actually have some calcium carbonate in there. It's not a lot, but trust me, water will find it. And when water takes that calcium carbonate out of that vinyl material, it becomes more porous. And when it becomes more porous, it can become wrinkled, especially with thermal expansion and contraction as the water temperature changes. So if you have a wrinkled liner or you have a fading liner, that is usually driven by an LSI violation. Aggressive water does that. It's not just chlorine. It's not just sunlight. So be aware of that. The point of this episode is to let you know that the LSI matters in all of these types of surfaces. In fact, I would argue it's more important in vinyl liners and fiberglass pools because there is really no mechanism for water to correct itself. No, of course it's a big deal in a plaster pool and you can get discolorations and you can get uneven carbonation and all that. But in those pools, water can correct itself. We are the ones that continue to screw it up. We are the ones who continue to try to beat the pH down to 7.4 because we were told to. We are the ones that try to maintain unreasonable numbers, depending on where we are, without factoring in things like water temperature or cyanuric acid or whatever. If we're not focused on the LSI, then you have a very high probability of damaging that surface regardless of what it is. See, water doesn't care about you or me. It cares about its own balance. So either you give it the balance it needs, or it's going to have to balance itself. And Tyler, in a fiberglass pool, it has no mechanism to balance itself. So it just lashes out. It's like you when you were a teenager, right?
Pretty accurate, yes.
It's just mad. So it starts destroying things. So I'm going to challenge you, since you don't really see a lot of these pools. Can you summarize what is fiberglass chalking and how can they prevent it?
Fiberglass chalking is when there's a bunch of cracks and voids, chlorine getting within them and oxidizing the actual material, and that's where you get the chalking.
Right. And what causes that material to crack like that?
Aggressive water, being aggressive on the LSI. It's unbiased, doesn't know where it can find the source, so it needs to balance itself back out, so it just starts eating.
That's right. That's right. Okay, vinyl liner. Fading and wrinkling is also caused by a low LSI violation, right?
Yes.
What can our listeners do if they happen to have a fiberglass or vinyl pool? What can they do to be proactive about this and prevent these issues from starting?
Pay attention to the LSI. Make sure you're aware of what the behavior of water actually is and start with a good foundation, which is calcium. Calcium is stable. We always recommend using calcium as your foundation. And in my opinion, everything from there kind of gets a little bit easier.
Mm-hmm. Well, we talked about it in a previous episode. I don't remember what number it was, but calcium is the bedrock of water balance. Go back and listen to that episode because it depends on your temperature extremes of where your calcium should be to allow you to maintain your LSI and contain your pH. It's all a part of the same physics philosophy that we're teaching here. You need enough calcium. So for those of you who do reach out with questions of saying, hey, my manufacturer says don't go over 200 calcium, have them listen to this episode. Have them reach out to me, podcast@orendatech.com. Visit our help center, ask.orendatech.com. This information's real. It's here. It's validated. Check our sources. Tyler, anything you want to add before we go?
Nope, I'm good.
Cool. It is really hot in this apartment because it's 117 outside. So let's end this and fix your air conditioning. I'm Eric Knight with Orenda and Hasa, and this has been episode 119. Thanks for your time.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.